Welcome to part 4 of this 7-part video series on troubleshooting stuck malolactic fermentations. In this video, we will be addressing the issue of low amino nitrogen and its impact on MLF. Join enologist and senior application scientist Duncan Hand from Hansen as he discusses the importance of adequate amino nitrogen levels, common causes of depletion, and strategies to overcome this challenge.
Hello, and welcome to this short video on stuck malolactic fermentation due to low amino nitrogen. So what is the problem around low amino nitrogen causing stuck MLF? Well, in order to complete MLF, a population of wine bacteria requires around 60 milligrams per litre of amino nitrogen. Of course, the concentrations of different amino acids and the actual individual amino acid demand from strain to strain can vary. However, the literature does suggest that 60 milligrams per litre is a good general rule of thumb for this. So what could be the causes of low amino nitrogen? Well, in most cases, you'd expect amino nitrogen to come through from the fruit, to be present in the wine during primary fermentation, and then be there to feed the bacteria during malolactic fermentation. However, if the starting fruit itself is low in nitrogen, this could mean that the wine is depleted by the time it comes to MLF. The problem can also be exacerbated by certain yeast strains which tend to have a high nitrogen demand, which means there's less nitrogen available for the bacteria later in the winemaking process. So how do we diagnose? What's the diagnosis for low amino nitrogen in a wine? Well, it's very easy. By running a PANOPA, or sometimes called a PAN test, on a UV spectrophotometer with an enzymatic test kit, it's easy to determine the concentration of amino nitrogen in a given wine. If it's below 60 parts per million, that clearly hints at it being the cause of stuck malo. Of course, if it's not possible to run this test, it's worth looking at the starting fruit and trying to understand what the starting YAN was, because a low nitrogen level at the beginning can point to this being a problem when it comes to malolactic fermentation. So what is the solution? Well, it's very easy. A low amino nitrogen can be addressed by using a specific MLF nutrient. In Hansen, we recommend our product Bactivate because it's designed specifically for wine bacteria, and it's different from a yeast nutrient, which is obviously designed for yeast. Bactivate is designed specifically for bacteria. And normally the standard rate would be 12 grams per hectoliter. The product itself is derived from an activated yeast. So you could grow yeast cells, give them heat shock, and then once the cells lyse, you have components in the cell wall as well as some individual components, which you can then use to compound a product. The final product itself is around 50% peptides and proteins, with a small amount of free amino nitrogen. Plus, you also have vitamins, minerals, lipids, and carbohydrates, all essential for growth. It's also important to note that if you're measuring PANOPA, if you dose with Bactivate, you might not actually see an increase in PANOPA itself. That's because the format of the peptides in Bactivate tends to be as short chains, whereas PANOPA just measures individual amino acids, which is more the format that you would expect amino acids to come through in fruit itself. Thank you very much for listening, and I do hope that was constructive.